Hi everyone. Okay, this is the second video in our little series on the cross product. In the first video, we looked at why you calculate the cross product in the weird way that you do with ijk as the first row and then a and b and take the determinant of that. Now we still have two things left to do. First, we have to show that the vector that we end up with is in fact normal to the base of the parallelepiped. And then in the third video, we'll show that that vector is has the same magnitude as the area of the parallel of the base. So first, we're going to look at how we're going to prove that that vector is in fact normal to the base. So first, need to show that A cross B is normal to AB. So this is just a big, complicated, or involved algebra problem, but it's fun to do and everything pops out in the end, so it's kind of cool. So I'm gonna go ahead and show it. So we're gonna call AB n. So n equals n1, n2, n3. A is a1, a2, a3. B equals b1, b2. Now, the way that you find, we have two vectors here. Two vectors always lie in one plane, because 3 points always determine a plane. So two vectors always determine a plane. There's always one plane, unique plane, that those two vectors lie in. So what we're looking for is the vector perpendicular to this plane. The way we can do that, we can't use the cross product because we're trying to demonstrate the cross product. But the way you can do that, that means if n is perpendicular to the plane, it's perpendicular to everything on the plane. That means that n is perpendicular to A and n is perpendicular to B. So we can dot these. So if we have that A dot n, if they're perpendicular, then the dot product is going to be 0, and B dot n is going to be 0 because it's perpendicular to each one of them. So if we write these out, we have that A1 n1 plus A2 n2 plus A3 n3 equals 0, and B1 n1 plus B2 n2 plus B3 n3 equals 0. So we have a system of equations. We have 3 variables, unfortunately, and only 2 equations. So what we're going to end up with here in this situation is not an answer. We're going to end up with a relationship. And if you think about it, that makes sense, because there are actually infinitely many vectors that are perpendicular to this plane, because we don't care about the magnitude. Any scalar multiple of this vector is also perpendicular to the plane. So we don't know what the magnitude of this vector is. All we know is that it's perpendicular. So what we're looking for here is actually the relationship, the proportions of them, the proportions of x, y, and z to each other. And then if you scale them, you're keeping in the same direction. You're just making it longer or shorter. So we can do that because we have 2 of these. So let's start by just adding these together, or actually subtracting this one from this one. So we have A1 minus B1 plus A2 minus B2 plus A3 minus B3 still equals 0. Keep n on one side. Let's solve for n first and see what we get. So move everything over. A1 minus B1 equals minus, 2b2 minus a3 minus b3 n3. All right, let's divide through. So n1 equals minus a2 minus b2 n2 over a1 minus b1 minus a3 minus b3, n2 over a1 minus b1 n3. Okay? Now let's take this, put it back into this, and see what we end up with then. So we're going to plug in this up here and then work from there. So we have, I'm going to take out the minus sign and then take it out of the a1 so that we have minus a1 and then now these will both be pluses. So minus a1, a2 minus b2 over a1 minus b1, n1 plus a3 minus b3 over a1 minus b1. Oh, that's n2, n3. Okay, so we took out the minus, and then we're multiplying this by a, and then we're plugging the rest of this into the n1. So we have this. Then just write out the rest of it, plus a2 n2 plus a3 n3 equals 0. So now we're going to divide out. They have the a1 minus b1 in common, so we can take that out too. So we have minus a1 over a1 minus b1 times a2 minus b2 plus a3 minus b3 plus a2 n2 plus a3 n3 equals 0. Okay, so now the next step, I'm going to multiply through by a1 minus b1. So I'm going to multiply this, each term, by a1 minus b1. So this will cancel. We'll have these, and then this will be a2 times a1 minus b1, a3 times a1 minus b1. I'm going to do that on the next page. So I'm just multiplying through each term by a1 minus b1. So these cancel. And we get minus a1 plus so minus a1, so this is what's left over when you get rid of the denominator, and then plus a2, a1 minus b1, and 2, whoops, I ran out of room, plus a3, a1 minus b1, and 3 equals 0. Okay? Now, let's just multiply this out. I'm going to multiply this out, and I'm going to move these two terms to the other side. So these two are minus on the other side. So it's going to be this equals minus this, okay? But I'm going to multiply everything out at the same time. So we have minus a1, a2 minus b2, n2. Wait, hang on a second. Did I mess up? Oh, I'm sorry. No, I'm going to do one more thing. what I'm going to do is I'm going to multiply out, and then I'm going to gather the ends together. So I'm going to have two n2 terms. This one and this one are going to be over here. Then I'm going to have equals, and then I'm going to move these two terms to the other side. So it's going to be, this is minus a1 times this, so this is going to be plus, and then that's going to be minus. So that's what we're ending up with now. So we have the n2s on the left side, the n3s on the right side. So we have plus a2 equals, move this over, a1 a1 times a3 minus b3, n3 minus a3, a1 minus b1, n3. Yes, 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 yes. Okay, now going to multiply everything out, and then a whole bunch of stuff is going to cancel. So we have minus a1, a2, n2, plus a1, b2, n2, plus a1, a2, n2, minus a2, b1, n2. You see what's going on here? Look. We have n2, and we have an a1 and a b2, a2 and b1. That's starting to look familiar. a1, a3, n3, minus a1, b3, n3. But interestingly, they're not quite there yet, right? Because this should be, because here we still have, the n is in the same column as one of the a's, and the same with here. So we're not quite there, but we're getting there. Minus a1, a3, n3, plus a3, b1, n3. Okay, so what can we cancel? We have a1, a2, n2, minus a1, a2, n2. Over here, a1, a3, n3, minus a1, a, n, a3. Wow. What's left? a1, b2, n2, minus a2, b1, n2, equals a3, b1, n3, minus a1, b3, n3. And now I can separate those terms out. So it's a1, b2 minus a2, b1, and 2 equals a3, b1 minus a1, b3, and 3. Now we're going to solve for, we're going to put n2 in terms of n3, so just divide through here, and we have that n2 equals a3b1 minus a1b3 over a1b2 minus a2b1 and 3, right? We divided this over to here. So n2 looks like this, has this relationship to n3. So now we're just going to pick a value for n3. Let's let n3 equal the denominator here. So let's let n3 equal a1b2 minus a2b1. Now if we plug this into n3, these cancel, and then in that case, then n2 will equal a3b1 minus a1b3. Look at that. We're very close now because n3 is the determinant of the other two, n2 is the determinant of the other two. Now we still have to get n1 here. So we have to plug these in to something up above. So we have to plug the values that we just found into our earlier equation here and see what we get. Oh, I see. Wait, get rid of that. So we're plugging the new values of N2 and N3 into this. Let me move to a new page while I have a chance. So N1 equals minus A2 minus B2 over A1 minus B1 N2 minus A3 minus B3 over A1 minus B1 N3. Now, our values for N3 is this, the other minor determinant, N2 is the minor determinant, so we can just plug those in here now and see what happens. So first of all, again, I'm going to take out the minus 1 over A1 minus B1. So N1 equals minus 1 over and then we have A2, B2, A2 minus B2, and then the value that we found for N1, which is everything left, right? That's N2 minus, no, plus, so we took out the minus, plus A3, B3 times the value of N3, which is A2, B1 minus A1, B2. Okay, now, a little more algebra, and it gets really cool here, that everything's going to fall out exactly the way we want it to. So let's multiply all this out and see what we get. So we have N1 equals minus 1 over A1 minus B1. Now multiply all this out. We have A2, A3, B1 minus A1, A2, B3 minus A3, B1, B2 plus A1, B2, B3 plus A2, A3, B1, right? Yes. Minus A1, A3, B2 minus A2, B1, B3 plus, because minus minus plus A1, B2, B3. All right, can we cancel anything? Uh-oh, wait, did I mess one up? Oh, wait, it's not here. Minus, plus, minus, plus. So 2, 3. Minus 1. Well, I messed something up somewhere. Oh, wait, that's what it is. What did I do there? Oh, that's what it is. This is backwards. This should be A1, B2 minus A2, B1. Right? Just make sure. A1, B2 minus A2, B1. Okay. Try that again. So these are all, these four are correct, but then it's A1, A3, B2, and then A2, A3, B1, that's minus, and then A1, B2, B3 is minus, and A2, B1, B3 is plus. Okay. So we have minus 2, 3, 1 and plus 2, 3, 1. We have 1, B2, B3 and minus 1, 2, 3. And what are we left with? So N1 equals minus 1, A1 minus B1. And what we have left is minus A1, A2, B3, minus A3, B1, B2, plus A1, A3, B2, minus, no, plus A2, B1, B3. Okay, now, can we take, let's see if we can gather some terms here. So we have, we're still 1 over A1 minus B1. We have A1 twice, so let's take out an A1. And what do we have left? We have A3, B2 minus A2, B3 minus, and then these we have a B1 here and a B1 here, so we can take out a B1. And I'm taking out a minus B1. So that makes this A3, B2 minus, I'm guessing, let's see if it's right. We took out the B1, A2, B3, right. Okay, what do we have now? This is the same as this. We can take this out, and what are we left with? Take this term out. Take that out, and we're left with A1 minus B1. Isn't that amazing? This cancels with this. This minus is the whole thing, is minused. So we're going to just rearrange those terms, and we end up with N1 equals, this is minus A2 minus B3. And then just to repeat, N2 is A3 B1 minus A1 B3, and N3 equals A1 B2 minus A2 B1. Whoops, wait, I didn't write that right. A2, try that again. A2 B3 minus A3 B2. There. So look, this is the determinant of with I, J, K, A1, A2, A3, B1, B2, right? It's A2 minus B3 minus that. For N2, it's A3 and B1 minus A1 and B3. For N3, it's A1 and B2 minus A2 and B1. So we did it. What did we just show? This vector is perpendicular to the plane because we started with, what we showed is from the system of equations that if you dot this vector with A, you're going to get 0, and if you dot this vector with B, you're going to get 0. So we try that? Let's try it. Let's just do A dot n. So we have A1 times A2 B3 minus A3, B2. A3, B1 minus A1, B3. Minus A1, A2, B3 plus A1, A3, B2 minus A2, A3, B1. I wasn't being very careful there. I hope I got this right. We have A1, A2, yep, those cancel. Those cancel. And those cancel. Probably could have done that to begin with, but it wasn't as much fun. So that equals 0. Check. Okay, well, so that's that. We've shown that the cross product vector is normal to the base. That was a lot of work, but sometimes I think it's helpful. It's fun to just do some algebra to keep ourselves from getting rusty. So we have one thing left to do with the cross product. That's prove that it is that its magnitude is equal to the area of the base. And then we're done with the cross product. A little video on the equation of the plane just to remind you, and then we'll be ready to look at the projective plane and homogeneous coordinates. So please come back. Okay, here is the link to the first video in this chapter. Here is the link to the previous video. Here is the link to the next video. And click here to subscribe, and please join me on Patreon. The link to that is below in the description. Thank you.